So let's talk about continuity and differentiability using a lot of graphs so we can visualize things. So imagine we have f of x is defined as x cubed minus 2x squared minus x plus 2. The point is it's a polynomial, okay? If you graph this object, let's do that next right here. So let's graph x cubed minus 2x squared minus x plus 2. Look at it carefully. Some key observations that we really have to understand, right? There are turns, but the turns are very smooth and gradual. That's a turn. It's pretty smooth and gradual. This is a turn and gradual. Look what happens when you differentiate this function. Okay, let's do another graph on the side here. And let's form the derivative of this function. So we know what to do. We can just use the power rule on each term independently. So it's going to be 3x squared minus 4x minus 1. I bring the 3 down, subtract 1, bring the 2 down. The derivative of negative x is 1. So look at that graph. You see this graph is smooth, and it's a parabola, and notice that its value exists for every x. So remember, this is f prime of x equals 3x squared minus 4x minus 1. Let me stress, it's a parabola because it's, and then regardless of which value of x you plug in, there's an output. The output tells you the value of the slope on the original function. So if I want the slope on the original function at x equals 0, I look here and I see that that slope is equal to negative 1. Okay, no problem, you see? If I want the slope of the original function at 2, then I look here and I see that the slope is equal to about 3. So it means an original function right there where my cursor is flickering, the slope on the original function at x equals 2 is gotten from the graph on the right side, and where the value is found to be positive 3. That's the connection between these. It doesn't matter which value of x I choose between the left and right sides. If I want the slope for any x on the left, I just look here, and the corresponding y-coordinate in the graph of the derivative is the slope. Now let's look at a different case. So take something like f of x equals x minus 1, and it's raised to the 1/3. So this is like the cube root, in other words, of x minus 1. If you graph this, look what happens. So graph it. You will have the cube root of x minus 1. And what's different here is this part right here. Let me zoom in on it, okay? Hopefully you can tell already. It's a little bit different because here the graph goes up. It seems to hit a vertical tangent line like this, and then it picks up on this side. Let's form the derivative of this function. F prime of x, again, you can just use the power rule. Bring the 1/3 down, okay? Then you have copy the x minus 1, and then you subtract 1 from 1/3. So 1/3 minus 1 is like 3/3, right, subtracted from 1/3, which is negative 2/3. So now let's graph this as a second graph. You could also just do it in both of these graphs. Let's do it that way, just for the sake of variety. You don't even have to do another graph. Maybe it's even easier, right? You just do everything in one graph. Let's enlarge this and like really focus on where things are kind of important. So graph the derivative now. You're going to have 1/3, and let's rewrite this in a more user-friendly format. So you're going to have 1/3. Now on the bottom, what you have essentially is, remember, the 3 tells you the index of the root, and the 2 just stays out, right? And the negative tells you put in the bottom. So you're going to have, in other words, the cube root of x minus 1, but it's squared. So now let's graph this. So 1 divided by 3, and the cube root of x minus 1 quantity squared. Look at the graph. That is the green graph. That's the graph of the derivative, the first derivative. Look at what happens in this function. Hopefully you can tell, right? Even if I do this a little bit, scrunch it down a little bit, that the green graph has a beautiful vertical asymptote through x equals positive 1. Right here. See this? This is a vertical asymptote right there. The reason, of course, is that in this derivative here, if you plug 1 into the denominator, you would have 1 minus 1, which is 0. The cube root of 0 is 0. 0 squared is 0. 3 times 0 is 0. 1 divided by 0 is undefined, you see? So the green graph, which is the first derivative, has a vertical asymptote. What that tells you is the following. That while we can find f of, for example, 1, no problem. It's just 1 minus 1 raised to the 1/3, but that's just 0 raised to the 1/3, which is 0. No problem. The function is continuous. Right? F is continuous at 1. But look at what happens in the first derivative if you try to do the same thing. Right? So f of prime of 1 would be equal to 1/3, and then cube root of 1 minus 1 squared, Well, if you work through this just ends up being 1 over 0, okay? I'll leave some of the intermediate steps to you as an exercise in terms of simplifying the expression in the denominator, but it gets the idea across. The point is this is D and E, correct? So what is this telling us? It's telling us that f of x is not differentiable at x equals 1. And visually speaking, what it means is the graph of f prime has some kind of defect in it, like a vertical asymptote. And that's how you should think about these things from a visual perspective, at least. But I'll leave it here. So if it's been helpful, insightful, please be sure to leave a like. I will see you in another video.